So today's topic is synchronous counter, design of synchronous counter. So we can design synchronous counter with the help of flip-flops. So there are four types of flip-flop: SR flip-flop, JK flip-flop, T flip-flop, and D flip-flop. So you can use any one of the flip-flop to design a synchronous counter. Or you can design asynchronous counter also. Today's topic we'll discuss about design of synchronous counter. So these are the steps. Step 1 is to decide the number of flip-flop. So with how many flip-flop you are going to design the synchronous counter. And step 2 is excitation table of flip-flop. So we should know the excitation table of flip-flop which you are going to design the counter. Yes. And step 3 is state diagram and circuit excitation table. Step 4 is finding the simplified equation using K-map. Finally, in step 5, we are drawing the logic diagram. So we'll go to the step 1 first. Okay, so in this question, for designing synchronous counter, step 1, that is deciding the number of flip-flop, is decided as 2. So that is what in the final step we have 2 JK flip-flop, and it is decided that you are going to use JK flip-flop to design the counter. It is totally the decision of the designer to choose which flip-flop and number of flip-flop. Okay, so step 1 decided JK flip-flop and number of flip-flop as 2. Okay, and going to step 2, that is excitation table of flip-flop. The excitation table is derived from characteristic equation table. So we should know this table. This is the characteristic equation table of JK flip-flop. So if you're not aware of the characteristic equation table, I'll make a video of it separately. So as of now, this is a characteristic equation of JK flip-flop. So the input JK and the state Q is taken as 3 input binary 0 0 0 0 0 1 0 1 0. It is filled till 1 1 1, and Q plus is derived with the help of normal JK flip-flop truth table. That is, when the input is 0 0, the output is previous state. When the input is 0 1, the output is 0. When the input is 1 0, the output is set, that is 1. When the input is 1 1, the output is previous state complement. What is the previous state? 0 1, and the complement of it is 1 0. So this characteristic equation table is known to you already. If not, you can watch another video for that. So now from this table, we are modifying it. So the modified table, input is taken as QQ plus and the output is JK. Okay, there are 4 states of input: 0 0, 0 1, 1 0, 1 1. Right? And the output is taken as JK. So you need to see here in this characteristic equation table, QQ plus is 0, 0 in two states. Yes. So seeing to the right side of that, when the input is 0, 0, output JK is 0, 0 here. When the input is 0, 0, output JK is 0, 1 here. So only one state is changing, 0, 0, 0, 1. Okay, here it is, input is 0, 0, which I marked with the circle. And here also the input is 0, 0, which I marked with the circle. Same output of that is 0, 0 and 0, 1. 0, 0 and 0, 1. Only the second state is changing. So you can mark it as 0x. Yes. Similarly, going to the second state, that is 0, 1. When the input is 0, 1, here I marked with the rectangle, right? When the input is 0, 1, and the input is 0, 1, here it is 1, 0, here it is 1, 1. So the output is 1x. You mark it. And then the third case, when the input is 1, 0, I marked it with the triangle 1, 0, 1, 0, and the output is 0, 1, 1, 1. So first place is changing, 0, 1, 1, 1. So you get x1 as output. Finally 1, 1. Here I marked it with this diagram. Here it is 1, 1. Here also the input is 1, 1. The same output, here it is 0, 0. Here it is 1, 0. So the first place is changing, 0, 0 and 1, 0, right? So it is marked as x0. So I hope you got this modified table. Now we got the second step, that is excitation table of flip-flop. We need to move to the third step, that is state diagram and circuit excitation table. So state diagram purely depend on the number of flip-flop. Here we have taken number of flip-flop as 2. Okay. So when the number of flip-flop is 2, state diagram input is taken as 2-bit numbers. Okay. And there is a formula 2 raised to n minus 1. And what is n? N is nothing but the number of flip-flop. What is the volume level here? I'll increase the volume little. So as per this formula, 2 raised to 2 minus 1. This 2 is nothing but the number of flip-flop. So you get 2 raised to 2 minus 1 equal to 3. So the number of states is 0, 1, 2, 3. That is nothing but S0, 0 state, S1, first state, S2, S3. 4 states. You get 4 states. So I hope the step 2 is over here. Coming to step 3, that is circuit excitation table. Here again, you need to mark a present state and next state. Present state is nothing but Q1, Q2. You need to fill it first, 0, 0, 0, 1, 1, 0, 1, 1, because number of bits is considered as 2. We have 2 flip-flops, right? Next state, if the present state is 0, 0, next state is going to be 0, 1, right? Present state is 0, 1, next state is 1, 0. Nothing but 0, 0 is 0, 0, 1 is 1, 0, 1 is 1, then next state is 2, 1, 0. 1, 0 is the next present state, the next state is 1, 1. 1, 1 is a present state, the next state is 0, 0. So you can refer the state diagram if in case 0, 0, 0, 1, 1, 0, 1, 1. The 2-bit binary combinations. Okay. Now, with the help of this, we need to find the output J1, K1 and J2, K2. J1, K1. So to find that, we need to compare this Q1 star. So when the input is 0 0, your output is 0x. So from where you get the 0x? From this table which we have. The input is 0 0, the output is 0x. Okay. Similarly, you compare all the states. So we did 0 0, next is 0 1. We are comparing Q1 and Q1 star. Next is 0 1. When the input is 0 1, you get 1x. You see this table, the input is 0 1, the output is 1x. Yes. Then 1 0, you get x 0, 1 1, you get x1. Similarly, for J2 K2, you need to compare Q2 Q2 star. So you get this circuit excitation table. Okay, that is step 3. So once you get circuit excitation table, you need to find the K map of this. So K map of what? So we have 4 outputs, J1, K1, J2, K2. You need to find the K map of J1, K1, J2, K2. I hope you all know how to do K map, because the first topic of digital electronics will be K map, right? After simplification of K map, we got the equation J1 is equal to Q2, K1 equal to Q2, J2 equal to 1, K2 equal to 1. Now, with this equation, we are going to design the synchronous counter like this. 2 flip-flop J1 K1 Q1, J2 K2 Q2, and output Q1, output Q2. Okay, and there are 2 flip-flop, so we need to give clock pulse connected to 2 flip-flops. Fine. And as per the equation, we got J1 K1 equal to Q2, right? So J1 is connected to Q2. Similarly, K1 right here. K1 is also connected to Q2. J1 K1 equal to Q2, and J2 K2 equal to 1, right? So J2, where is J2? Here. J2 equal to 1 and K2 equal to 1. So this is how we design a synchronous counter. And the clock is given simultaneously to both the flip-flops, so it is called simultaneous clock. Okay. So this topic is over here. Thanks for watching.